In our last part, we have discussed about supervised learning. In this particular video, we are going to discuss about the second method of machine learning, which is known as unsupervised learning. So basically, this is unsupervised learning. Now in this, what is the difference? It is this unsupervised learning is an exact opposite technique of supervised learning. Now, if you remember the supervised learning, it uses these labels, that is label data, to train the model. In the unsupervised learning, it does not need any label data to train the model basically, right? Because it is the exact opposite technique of supervised learning, and it does not need any human involvement as well. So there were two main factors of supervised learning. One was using label data, because that is the foundation of supervised learning, that more the accurate you use your labels, more the accurate will be predictions. But in the unsupervised learning, this particular you know case is not there. It does not need to use any labeled data. It uses unlabeled data basically to train the model, right? So, and there is no human involvement as well that is needed, right? So basically these kinds of learning methods are used in clustering technique, right? The main the various techniques which are there for the machine learning, for clustering techniques, these algorithms are, I mean, the learning methodologies are used. Now what happens here, that this unsupervised learning is good in pattern matching, right? Now just by seeing the shapes, right? Even though let's say we don't know what is a circle, what is square, we don't know this is a circle. When a shape of this kind of a geometry comes into picture, then we call it as circle. This is a square. Let's say we don't know that. That means we don't know the labels, right? Because unsupervised learning uses unlabeled data to train the model, right? But still, by just looking at these shapes, I can still categorize those as, or I can still make their categories as like this. And these are the shapes which look similar to me, right? Because there were two circles, but this is a square, sorry, this is a shape, and I really don't think that this shape is similar as that of the circle one, so I'll make it as a different category shape. Same thing will happen with this square as well, that but this shape looks like this one, so this particular model will make it here, make the clustering here, then a new shape. Yeah, this is neither, this particular shape doesn't look like the first shape or the second shape, so third category. And same thing with here, right? And then one more circle remains, which we have already written it here, but this shape looks like this one, so it will go here. This particular model will predict that it is. So all these kinds of pattern matching, right? So here what has happened, this is predominantly what we have done here is pattern matching basically, and these kinds of techniques are used in pattern matching algorithms wherever there is a necessity to find some kind of patterns, right? Like for example, fraud detection. So whenever any fraud happens, it's a non-linear pattern that comes into the picture, and these kinds of algorithm or these kinds of learning methodologies helps to find the patterns, right? Like for example, anomaly detection, pattern matching, these are kind of examples of unsupervised learning, and the technique which uses this particular learning method is known as clustering technique, right? So clustering technique, right? So advantages, it does not need any big volumes of data. It just, with few inputs, you'll be able to make these kinds of clustering or patterns. And obviously, you don't need basically any human involvement. Okay. Now, what are some of the problems that you can face if you use this particular algorithm? It is basically very difficult to evaluate accuracy of the result, right? Because let's say if we started giving lots of inputs to this trained model, then how you will calculate the accuracy of algorithm, because no human involvement is here. Even though let's say it make a little wrong prediction or undefined prediction, it is not possible to point out towards the accuracy of the result, because in the unsupervised learning labels are not there, right? So that is sometimes you may get some confusing results. Basically, I'll not say the wrong results, but confusing results you may get. Then what is the second problem, or where it may slow down, is it is very hard to interpret the results and turn them into the actionable data. Now what I mean here is, basically it is very hard to interpret these results, that okay, that's fine. Using this particular learning method, we got some kind of clustering, that okay, these two things, these two objects look similar, these two objects look similar, these two objects look similar, but what next? That's fine, you gave us the category, you gave us the classification, but to use this particular data to do some kind of action, we call it as actionable data, right? You still have to have some kind of human involvement, right? Let's say that, like, you take some example. Okay, you found, like, you using this particular algorithm, or using your fraud detection model, you found that yes, fraud has happened, but what next? you know how to deal with that particular thing is something where human involvement is still needed. So moreover, this is kind of a learning where pattern matching can be done, with a that's a strong point of unsupervised learning. Okay, so that's it, guys. That's it for this unsupervised learning part. In this video and the previous one, we have seen methods of machine learning, supervised learning, unsupervised learning, and their differences. Okay, I hope you must have found this particular tutorial very useful in terms of understanding various methods and overall the fundamentals of AI and machine learning. Do like, share, and subscribe to my YouTube channel. Thank you very much.